Assalamualaikum and hi. So today we proceed with topic 3, dynamic of linear motion. First learning outcome is about momentum and impulse. So 3.1a define what is momentum and impulse. Okay, so look at momentum. Momentum is defined as the product of mass and its velocity. So all objects have mass. So if an object is moving, then it has a momentum that we call it as mass in motion. Okay, so the unit for momentum is kg/ms because mathematically we can rewrite the equation of momentum P is equal to mv. Okay, so P is momentum, m is mass in kilogram, and v is velocity in ms-1. Okay, momentum is a vector quantity. So vector quantity means have direction and magnitude. So in the same as the direction of velocity. So momentum is a vector quantity that have direction of momentum is the same as the direction of velocity. So since the momentum is a vector quantity, it has direction and can be resolved into x and y component. So let's say we have a P here. So you can resolve in component x and component y. Okay, here the example for momentum. So we have a train with 2000 kilogram and move with 20 meter per second. So a train can have a large momentum even if it's moving very slowly because it has a large mass. Mass tinggi, so momentum juga akan tinggi. Okay, how about this? Okay, we have a bullet with the lowest mass of 0.02 kilogram and moving with 200 meter per second. So a bullet can have a large momentum also even if it has a small mass because it is moving at the high velocity. So velocity tinggi, maka momentum juga tinggi. But the more momentum of the object gathers, the more difficult to bring it to stop. Okay, so maksudnya itulah momentum. Okay, let's say we have a car 2000 kilogram move with velocity of 80 meter per second. So the car in motion have a momentum because have mass and velocity. So if the car slam a brake to avoid the collision, so the car will skid at a certain distance. Okay, so this force must be applied over some duration time to bring moving object to stop. Instead, maksudnya kereta tu kalau dia nak berhenti, dia kena ada satu force yang react pada masa tersebut untuk menyebabkan velocity dia changing. Okay, velocity daripada 80 kepada 0, maksudnya ada perubahan velocity. Jadi mesti ada force yang apply pada masa itu. Okay, so force yang kita apply pada duration time itu kita namakan dia sebagai impulse. Okay, so means that kalau F acting over a long time means that take your foot off the gas and let the friction from the road slowly stop the car. So maksudnya waktu itu you supply force adalah rendah lah, tapi masa untuk kereta tu berhenti adalah lebih panjang. Okay, so kalau firmly apply the brake to the tires, so maksudnya you tekan brake, dan F waktu tu akan menyebabkan F waktu tu adalah tinggi lah, akan menyebabkan kereta tu sudden stop lah, maksudnya berhenti cepat lah. Okay, in a short time. Okay, so maksudnya kena tahulah force yang kita apply untuk menyebabkan kereta tu berhenti means ada perubahan velocity changing, maka momentum juga akan berubah. Bila momentum berubah, maka dekat situ kita boleh katakan impulse akan terhasil. Okay, so what is impulse? Okay, impulse is defined as the product of an average force F and the time interval delta t during the force act. Okay, so impulse is equal to J F delta t. So the unit of impulse in kg/ms-1 or Newton second. So impulse is a vector quantity and have the same direction as the average force. Okay, ni adalah average force lah, ataupun you panggil selalunya impulsive force. Okay, since the impulse is a vector quantity, it has direction can be resolved into x and y components, same as momentum. Okay, but symbol that we use is J. Okay, so based on this, maksudnya impulse ni berlaku mesti ada perubahan velocity lah. Okay, perubahan velocity. So nanti kita tengok pada momentum theorem lah. Okay, so when the two objects in collision, the impulsive force F against time t graph is given by the area under the graph. So area under Ft graph is represent impulse. Ni adalah contoh lah. So area under the graph ni, you kira lah, you akan dapat 20 newtons second. So this one 15 newton seconds depending on the shape of Ft graph lah. So area under the graph adalah merujuk kepada impulse. Yang ni kena integrate lah. So ini tak adalah dalam syllabus kita. Okay, so next is impulse momentum theorem. So when a net average force act on the object during a time interval delta t, so the impulse of this force is equal to the change of momentum of the object. So impulse juga kita boleh denote dia sebagai change of momentum. Change of momentum means mv minus mu. Kalau ada perubahan momentum, mesti ada impulse. So contoh macam kita case tadi bawa kereta. So kereta kita akan untuk elak macam kereta sedang bergerak dengan 80 meter per second, and then untuk elak collision berlaku, kita akan apply brake pada satu duration time, and then car to stop. So maksudnya ada perubahan velocity dekat situ kan, pada contact time berapa. So at this moment kereta tu akan mengalami impulse lah. Ataupun awak kata awak baling satu bola, and bola tu langgar dinding dan dia berubah velocity, atau kita kata velocity ni boleh berubah dalam dua cara kan. Velocity sebab dia ada direction, even dia punya nilai sama, pergi 20 patah balik pun 20, tapi dia ada direction. Satu pergi positif 20, patah balik negatif 20, maksudnya dia still lagi ada perubahan momentum. Okay, so kena faham lah, ada objek yang ada contact pun juga akan mengalami impulse. Okay, sebab dia contact tu yang menyebabkan dia akan berubah velocity. So kalau kereta tadi tu dia punya impact tu adalah friction lah. Okay, so this is impulse lah. You boleh create lah sama ada you nak guna J is equal to F delta T, ataupun J is equal to delta P, or J is equal to MV minus MU. It's depending on the question yang ditanya lah dalam soalan. Okay, next subtopic is about momentum and impulse 3.1b. Solve problem related to impulse and impulse momentum theorem. So dia limit pada one dimension saja. Jadi impulse you tak dia melibatkan resolving vector lah. Okay, so example, the face of the golf club exert an average force of 4,000 Newton for 0.02 second. What is the impulse imparted to the ball? Okay, so nak cari impulse is equal to F delta T, where F supply to the ball is 4,000 Newton. Okay, times with the time contact is 0.02. Okay, maksudnya force to contact dengan ball. Okay, face of the golf club tu dia contact dengan ball adalah pada 0.02 second. So jawapan untuk impulse is 8 kg meter per second. Okay, next we have Paul and Nick push nuts broken down car down to the road. So at the time t equal to 0, they push with a force of 1,000 Newton. Okay, 1,000 Newton. They reduce their force gradually to 500 Newton. Reduce gradually ke bawah sebanyak 500 Newton for another 5 second. They reduce the force gradually to 500 Newton at the time t equal to 5 second. Okay, reduce during 5 second and then continue pushing with the constant force. Constant lah. 500 dia kekal selama lagi 5 second. So we'll be get 10 second lah totally dia tolak kereta tu. If the car is 1,500 kg start from rest, what is the final velocity at the end of the 10 second? Okay, so untuk dapatkan jawapan final velocity, awak tahulah force versus t, area under the graph is represent impulse. So based on impulse, kita kira lah area under this graph, ini adalah luas trapezium. Okay, plus with the square. Okay, so 5 times 500, so you dapat 6250 Newton second, and then you relate dengan change of momentum lah, di mana mv minus mu, you akan dapat nilai final velocity. So I get 4.17 meter per second.